Welcome to today's class where we are looking at indices and logarithms. So accompany me to the end. I'll be giving you very many examples on indices and then very many examples with logarithms. But first we shall begin with the indices because the understanding of indices will then help us understand logarithms. So let me share my working. Now, so first we begin with the definition of an index. And I've said that if there are many, the plural of an index shall be indices. Now, and then I said that an index is just the power to which a number is raised. For instance, if a is raised to n, then this n is called an index. And a shall be called the base. Or e.g., if I have 5 raised to 3, then here 3 is the index. 3 is the index here. And 5 is the base. 5 is the base. If I have 7 raised to x, then x will be the index. X will be the index. So the power is the index. And then the base 7 is the base. So 7 is the base. So we only need to know what an index is and what the base is, and then we look at examples. So let's just look at examples. Just before we look at examples, I begin with the laws of indices. And I've said that if the bases are the same, if I have a raised to p times a raised to q, then I would add the powers. I'll add the indices when the bases are the same. And that is when you're multiplying. So for instance, if I have 5 raised to 2 multiplied by 5 raised to 3, so this will be the same as 5 raised to 2 plus 3, which is 5 raised to 5. So we shall be adding the indices in cases of multiplication. And in cases of division, we'll be subtracting the indices. So for instance, if I have a raised to p divided by a raised to q, then I have a raised to p minus q. That is, for example, 3 raised to 7 divided by 3 raised to 2. This is the same as 3 raised to 7 minus 2, or 3 raised to 5. So we subtract the powers in cases of division when we have the same bases. Now, I've also said here that a raised to p, then the whole thing raised to q will be the same as we just multiply these powers pq. So it will be a raised to pq. Then I've said that a number raised to 0 shall be 1. So these are the laws of indices, and we want to use them to do examples. Now the first example is this. Evaluate 3 raised to 2 times 3 raised to 7. So the solution to this will just be 3 raised to 2 plus 7, which is 3 raised to 9. So just add the bases, the powers. Since you realize that this base and this base are the same. Now what about here? This is a division. Now if you have a calculator, you can do 3 raised to 9 and find out what that one is. If you have a calculator, you can do that. Now this is 7. This is a division. So it should be 9 minus 6, which is 3. That's how you do that. And then number 3, we have 2 raised to, we just multiply the powers, and 3 times 2, that gives us 6. So that becomes the answer to this question. So it's very easy when you are dealing with indices, and we just need to know how do you multiply. How do you multiply if they're given a number raised to, and if the bases are the same. the bases are the same and you're multiplying numbers. And the bases are the same, then you're dividing the number. As for these rules, these laws of indices are then very much important. Now, so let's look at the next part. I just want to look at this example. Just a minute. The example says simplify this. Now, so let's just do the first question, our solution, and we're using the laws of indices. I have a raised to 5, b raised to 2, divided by 2, a raised to 2, and b. This is b raised to 1. Now, what is the answer to this? Just simplifying. I can see an n in the numerator and another n in the denominator. So when they are brought together, that means you have to subtract the powers. So I want to take all the unknowns above, a and b. I want to take them to the numerator. So I'll have a raised to 5 minus 2, which is a raised to 3. And then b raised to 2 minus 1, this one here. So that gives me b, then out of 2. And that is the answer to this question. So I just took the a raised to 2 up above. That means I took a raised to 5 divided by a raised to 2. So that one is 5 minus 2, which is 3. Then I also took b raised to 2 out of b. And we have already said that this would be b raised to 2 minus 1, which is just b. That's how you arrive at this solution. Now, I want us to look at part 2 of the question. And what does part 2 say? Part 2 says, find the cube root of 27 a raised to 6, b raised to 3, divided by a raised to 3, b raised to 9. So that is the question that we want to do. And so I have a raised to 6 in the numerator and I have a raised to 3 in the denominator. So this is the same as the cube root of 27. I just want to simplify first of all. A raised to 6 minus 3 would be a raised to 3. B raised to 3 minus b raised to 9 would be b raised to negative 6. Then I get the cube root. That means multiply this power here by a third and this other power by a third. And you know that the 27 is the same as 3 raised to 3. So in fact what I have is the cube root of 3 raised to 3, a raised to 3, b raised to negative 6. Now, so just multiply these powers by a third, and what you get is 3 a and b raised to negative 2. And that becomes the answer to this question. We're just simplifying, making it a bit simpler than it is. So what I'm emphasizing is this part. 6 minus 3 is 3, and 3 minus 9 is negative 6. And that's how we divide these numbers. And so after that, getting the cube root just means multiplying these powers by a third. So 3 by a third is 1. 3 by a third is 1. Negative 6 by a third is negative 2. That is the answer. Or else to look at question 3. Question 3 is interesting. It's 2 out of 3 raised to negative 2 times 3 out of 2 raised to negative 2. Now, just before I do this, note that if I have 2 raised to negative 3, this is the same as 1 out of 2 raised to 3. If I have a raised to negative 1, this is the same as 1 out of a raised to 1, or just 1 out of a. So that means that if you have one negative index, we can write it in positive as a positive index by dividing this into 1. Dividing this into 1, then you change the sign of the index here. So that's what I want to do. That's what I want to do for this question. I want to write these indices as positive. That's why I want to begin from. But this will just be 1 out of 2 out of 3 square times 1 out of 3 out of 2 square. Now, just one thing that I want you again to know is that if I have 2 out of 3 and then square it, it's the same as squaring each of these numbers. I'll get 4 out of 9. I'll get 4 out of 9. And if I have 3 out of 2 and square it, I'll get 9 out of 4. So that is very important. So let's just now simplify this one further. So that means what I have here is 1 out of 4 out of 9. And this one is 1 out of 9 out of 4. And you know how to divide this. You know how to divide this. This one, if you're doing it, what I have there is something like this. 1 divided by 4 out of 9. That's what I have there. And we know what to do here. That we would then change this division to multiplication and change this to its reciprocal. That's what we're supposed to do. So this part is just this part. This part here. This part is just this. So the whole of this becomes 9 out of 4, and the whole of this becomes 4 out of 9. So this is 9 out of 4, and this is 4 out of 9, which is 1. Which is 1. And so that's how we do this question 3. Let me now do question 5. No, question 4. Now, question 4, you can see we have negative indices here. And so what I have there is 2 raised to negative 3 times 2. And you can remember our other rule there that we then multiply these powers. The rule there, the rules above, you can remember that. And this is 2 raised to negative 6. What about this one? 2 raised to negative 8. So these are negative indices. Let us write them as positive. It will be 1 out of 2 raised to 3. And what about this one? It will be 1 out of 2 raised to 12. I just multiplied 3 by 4 to get it 12. And what about this other one? This other one will be 1 out of 2 raised to 6. And this one 1 out of 2 raised to 8. So what do we have in the numerator? What we have in the numerator, you can, in fact, we would have begun by adding these powers because it's multiplication. Would have begun by that. That would have been a bit simpler. So let's use the simpler one. Let me just make it more simpler for us. This other one is becoming longer. Let me just use the first law. The first law says that when we multiply, we add the powers. So this is 2, negative 3, negative 12 out of 2, negative 14. So I just added these two powers. And so this is 2, negative 15. And this one is, let me just write it here, 2, negative 14. And so what it says is that if it's division, we subtract the powers. So that means we would have 2, negative 15, negative, negative 14. And this negative and this one is positive. So that means what we then have is 2 raised to negative 1 or just a half. 2 raised to negative 1 or just a half. So a half is the answer. And you can see what I have done. You may also want to do the way I was doing it earlier, but I then changed my mind to make it a bit simpler because you already know the rules here. That when you are multiplying, you add the powers. So we just added the powers here. That will be, and you know that this is negative 12. So negative 12 plus negative 3, that gives us negative 15. And you know that this is negative 4 and negative 8. We add those to get negative 14. And because of division, and since we have the same basis, we need to subtract the powers. So negative 15 minus 14 is the same as negative 15 plus 14, which gives us negative 1. And so we write it as a plus 2 to get a half as the answer. Now, I want us to proceed to the other question. Question 5 says simplify. Now, I just want, it says 81 raised to a third. That means get the cube root of 81. It means get the cube root. So that 81 raised to a third, this is the same as saying cube root of 81. Now, so let me see. I can write 81 as a product of its prime factors. So 81, I know that 3 would go there, 2, 7, and that 3 will go into 27 9 times, and that 3 will go into that 3 times, and 3 will go into itself 1 time. That means that 81 is the same as 3 raised to 1, 2, 3, 4. But what I want is the cube root. What I want is the cube root of 81. So therefore, 81 raised to a third is the same as 3 raised to 4 times a third. This is 3 raised to 4 out of 3. So that is the answer to this question. That is the answer. And just see what I've done. And the question was just that is simplify. So I'm just simplifying. And I'm saying 81 raised to a third is the same as getting the cube root of 81. So I then decided to write 81 as a product of its prime factors. And I can see that it can go here 2 times. It remains 2 into 21 7 times. And 3 will go into 27 9 times. 3 will go into 9 3 times. 3 will go into 3 once. That means 81 is the same as 3 raised to 4. But I want the cube root of 81. That means getting the cube root of 3 raised to 4. In other words, 3 raised to 4 times a third. These are powers. So a third is also a power. So that gives us 3 raised to, this is a power. Let me just write it properly here. 3 raised to 4 out of 3. This is not a mixed number. Don't take it as a mixed number. No, it's not. Now, what about this other one? 16 raised to 3 out of 4. That is number 6. 16 raised to Negative 3 out of 4. What is 16? Product of its prime factor. 2 goes into 16 8 times. 2 goes there 4 times. 2 goes there twice. And 2 goes there once. So 16 is the same as 2 raised to 1, 2, 3, 4, raised to 4. And then raise this to negative 3 out of 4. This is the same as 2 raised to a third. Because 4 will cancel with this other 4. 2 raised to a third. Or if you want, you can write as 1 out of 4. Or if you want, you can write it as 1 out of 8. 1 out of 8. You can write it like that. Now let's look at the next concept. The next concept is the concept of natural exponential function. Natural exponential function. Now we've been talking of indices, and I've said that we can have a number like 2 raised to another number, and that here the base is 2 and 5 is the index. And I also talked of, like, for example, if I have this, then 7 is the base and x is the index. What about the natural exponential function? I've said that a function is e raised to x is the natural exponential function where e is the base and this base equals to 2.7182 and so on. So this one you can find it on your calculator. If you just press E on your calculator, check your calculator and you'll find there is an E on your calculator. When you press it, it will give you this value. Now, so what you notice that some calculators may require you to press E just direct, and others will first of all want you to press shift. So understand your calculator, what your calculator wants, and then it do what it wants. If it requires you to press shift and then E, then you can just do that. The others that will require you just to press E straight away. But when you, whichever way, once you press it, it gives you E to be this. So this E now is the best for the natural. This E is what we call the exponential, the natural exponential function. Now, e raised to x, naturally, e raised to x, when it becomes an exponential function. So the all of this e raised to x is the exponential function. And the base here is now e. The base is e, not 2, not 7, and so on. Now, so we just want to use our calculators to evaluate this. So I've said that E is on your calculator. You just press E and then raise to 2.5. And I've said here some calculators will require to just press E and then write 2.5. Others will require to press shift and then E. It will bring a bracket, something like this, meaning raised to. So it will be E raised to, if you press your calculator, and then with a bracket, inside that bracket write 2.5 and say equals, press equals, see what it brings. So these ones I just want us to use the calculators. So there's nothing much here. Just go to your calculator and press these things. I'll also be using mine. I'll also be using my calculator so that we compare the answers. Now understand your calculator. So press e raised to 2.5 and see what you get. I'm getting 12.18. If you have a problem with that, you can just text me under the comment section. Under the comment section, text me what your problem. If you cannot understand understand how to press e raised to 2.5, then you just write to me in the comment section. I can see how to guide you. But as I've already said, that some calculators may require to press shift first of all, and others may just require to press E and then write 2.5. Others may not require the brackets. Others may not require the brackets. They just write E and then 2.5. Others may require E and then bracket 2.5. So you just have for you to understand your calculator, what it requires, and then you get used to using your calculator. Now, so e raised to 2.5 gives me this. What about 23.2 multiplied by e raised to 0.12? So that one you can just do it on your calculator the way it is. 23.2 and then multiplied by e. You don't even need this multiplication, but there's no problem. You can put then 0.1512. Do what you get. I was getting the whole of this. I was getting that it would be 23.2, but this e raised to 12, e raised to 12 was giving me what is in my brackets. So that when I multiply it, I then get this. Now you can do even this. You can do this other one. 12.5, no, 12.3 times e raised to negative 1.5. You can do it in your calculator, but you can also, you notice that this one can also be written as 12 out of e raised to 0.5. Yes, we've already talked about this. We've already said that 2 raised to negative 1, negative 2, shall be 1 over 2 raised to 2. So the same thing, e raised to a negative number can be written as e raised 1 over e raised to that number. So it can be written that way. So you may want to do the way it is on your calculator, or you may want to change a bit and write it in this form, then do it on your calculator. Whichever way you choose, you must be able to get the same. Good. So you can do even this other one. You're just using the same procedure. Let's look at the next concept. The next concept, as I said, is the concept of logarithms. We've already looked at indices, and under indices, the most important thing you need to know to multiply and how to divide and so on. Those laws of indices, you need to know them. Now, logarithms, I begin by defining what a logarithm is. And is a function of this form. A function of this form. The log of y to base n. And the important thing about this base is that it must be greater than 0 and it should not be equal to 1. This base should be greater than 0 and it should not be. So you cannot have something like this. Log of 3 to base 0. You cannot have something like that. And then we cannot have something like log of 7 to base 1. Let's avoid those. That is what this condition here says. Is that the base must be greater than 0. And it should not be 1. So the base can be 2, can be 3, can be anything greater than 0 and not equal to 1. Even a half is okay. Even a third is okay. Even negative, no, negative, no. The base can never be negative. That's why he's saying that it must be greater than 0. Even 1 out of 7 is okay. Even 13 is okay. 14 is okay. Anything greater than 0 and not equal to 1 is okay. Good. So you can read what I've written here. I've said that in this case, we say that y is the logarithm of x to base n. y is the logarithm, or this y is the logarithm of x to base a. So how do we read this? The log of y to base a, that's how I read it. X equals to the log of y to base a. That's how I read that. Now, so you can write this in exponential. If you're given x is the logarithm of y to base a, then you can write it in index form or in exponential form. And so what I've said is that for us to write this in index form, we drop the log here and interchange the power. So what I then do is that y goes to where x is and x goes to where y was. So this one is the index form of this logarithmic form. So this is the logarithmic form, and it can be converted to index form. And that's what I've written here. I've said that we can write this logarithmic function in exponential form or in index form. And you can see what I've done is that where this power here, and achieve the x, so x comes where the power was, and y goes to where x was. And so that means that we can interchange from logarithmic form to index form or to exponential form and vice versa. We can do that either. And I've shown, I've said thus, if I have the exponential form, I can write it in the logarithmic form by introducing log here, and then x goes to where y was. If x goes to where y was, you can see that x goes to where y was, and I say log. So then this 2 becomes the base. And so I'm having that. So if I have this index form or exponential form, I can write the logarithmic form by saying x goes to where y is, and I say log, then there is the log of y to base 3. Log of y to base 3. So that's what I want us to look at. I want us to look at how to convert from one form to the other. And I begin with the first example. Example says, write the following in exponential or index form. So we've been given in a logarithmic form, and we want to write in index form. So solution, to write this first one in index form, 3 goes to where y is, we drop the logarithm, so it will be 2 raised to 3 is 8. So 3 goes to be the power, and 8 goes to where 3 was. So just in the chain. And 2, now the base here is silent, and whenever the base is silent, we take it to be 10. Whenever the base is silent, we take it to be 10. So this thing, it has no base here. We have not written the base. We take it the base to be 10. So this question here is the same as the log of 100 to base 10 is 2. So to write this in index form, let 2 go to where 10 was, where 100 was. So the 10 raised to 2 is 100. Number 3, here the base is the 1 over 5, and we have 25 here to go to where negative 2 was. That means 1 out of 5 raised to negative 2 would be 25. Now, when you write this one as 1 out of a 50, and then raised to 2, so that this one is positive, you would then find that 5 raised to 2 is 25. We've done this one before. We've done this one before. Although you can leave it at this point, but there's no harm in going further, simplifying this one further to come to 5 raised to 2 is 5. Now, I already have the answers to this question. Let me just show you what I had done earlier. So this is what I've done earlier. Now let's look at this other question. This one you can just use a calculator. I had already said that this one is log of 100 to base 10. So that your calculator can do this. You are given log of anything to base 10. Anything to base 10. Your calculator can do it. So just you press log and then you press 100 and say equals. Your calculator should be able to give you 2. Your calculator should be able to give you 2. And the same to this. So we know the base here is 10. It is silent here, so we say therefore it's 10. But your calculator can do it the way it is. Just press log, then brackets 20, close the brackets, equals. Your calculator should be able to give you this. There's this natural logarithm, the natural logarithm ln. Natural logarithm ln of 4. Your calculator has ln. Your calculator has ln. So just press ln on your calculator, brackets 4, and press equals. And you should be able to get this. And even this one, your calculator already has it. This is natural logarithm. Natural logarithm. It is ln. Natural logarithm. So just press your calculator. ln is on your calculator. 0.3 and put it in. Now, so when the base is silent here, we say that we know that it will be 10. Now, what is ln? Natural logarithm ln of 4. This is just the same as log of 4 to base e. The same as log of 4 to base e. And we know what e is. We know what e is. E, we had already defined the e. But still, I've said just use your calculator. We shall come here later and see how we relate these ones to get the answer. Now, there's something I've written here that the relationship between exponential and logarithm functions is very vital in evaluating logarithms. And this is shown in the following example. So the example is here. The example says, evaluate the following logarithms without using a calculator. So we are not required to use a calculator. And I've said that we shall be using the relationship between exponential form of logarithm function. So for example, if I wanted to do this question, or I've already done it here, you can follow. I want to find what this is. I will do the way we were taught at lower level, that we let it be an unknown. So we let it be x. We let x be the log of 243 to base 3. Because this is what we want to get, and we don't know what it is, so we let it be x. So this is logarithmic form. Then we write it in index form. When you write this in index form, you remember that x would go to where 243 is, where the power is, and 243 will go back. So we shall then have 243 equals to 3 raised to x. Now, so we were told to do this question without using a calculator. That means that 243 can be expressed in terms of 3. Whenever this question is asked, then it means you must think of a way of how to write 243 in terms of 3. Let's just see. 3 into 243. How many times can it go there? I can see that 3 can go into 24 8 times and into 3 once. 3 can go into 81 twice here and then 7. 3 can go here 9. 3 can go here 3 times and 3 can go here 1. So 243 in fact 243 is just written as 3 raised to what? 1, 2, 3, 4, 5. 3 raised to 5. So what I have is 3 raised to 5 equals to 3 raised to 3. No, 3 raised to x. 3 raised to 5 equals to 3 raised to x. When the bases are the same, then it means the powers are also the same. So what that means that x equals to 5. When the bases are equal, the bases are the same, 3, 3, then it means we can equate the powers. And that's what I did. That's what I did. And then therefore it means that the log of 243 to base 3 is 5. I'll be showing you how to do this question later using a calculator. Of course, your calculator has base of 10. And this base is not 10. So I'll be showing you how to do this question using a calculator later. But look at the steps that we were told to find this, and we didn't know what it was, so we had to let it be x. And remember that this is logarithmic form, which can be expressed in index form as this. And you already learned how to express logarithmic form in index form in our earlier exam. And so, since the question was asked to be done without a calculator, we thought that this 243 can be expressed in terms of base of 3. So we thought to find out that it would be 3 raised to what? We discovered it would be 3 raised to 5. So what it means that this 243 is the same as 3 raised to 5. So what this statement is saying is that 3 raised to 5 equals 3 raised to x. The bases are the same. That means we can equate the powers, which means x will be 5. Now, so for the sake of writing your notes, I have already done this question here. So you can just write, these are the notes. I've just said let this be x, then that. Every step that we've done is just. Let's look at the second example here. But I'll not do all these questions. I'll not do all these questions. Once I've done 2 or 3, be able to follow up and do the rest. Now, so what was the rest? What was the other one? The other one was log of 64. Let's go. So again, I just say let it be x because I don't know what it is. Let it be x. And then notice that this is logarithmic form. So to write in index form, it will be 4 raised to x out of 64. Four raised to x. No, 4 raised to x is 64. And then check if 64 can be written in terms of 4. Just check. 4 goes into 64 16 times. 4 here 4 times, and 4 here 1. That means 64 is the same as 4 raised to 3. 1, 2, 3. That's what I wrote here. That's 64 is the same as 4 raised to 3. And so 4 raised to 3 is the same as 4 raised to x. The bases are the same. It's 4, 4. That means we can now equate the powers. 3 is x. And the other one was that we were to find the log of 64 to base 2. But find that. So I say let it be x. Let it be x. Let x be that. It is in logarithmic form. This logarithmic form. Now write in the index form. X comes where 64 is, and 64 goes where x is. So 64 equals to 2 raised to x. And then write 64 in terms of 2. Write 64 in terms of 2. How many times is 2 going to 64? 32 times. 2 into 32, 15 times. 2 into 16, 8 times. 2 into 8, 4 times. 2 into 4, 2 times. And then finally 2 into 2, 1. So 64 is the same as 2 raised to 1, 2, 3, 4, 5, 6. The mass 2 raised to 6. So that's why you see I've written 64 is the same as 2 raised to 6. So that means this statement is the same as this. Same as this. It is to form 2 raised to 6 is equals to 2 raised to x. Now the bases are the same, so that means you can equate the powers. It's very easy. Very easy the way you are saying it. Let's look what these are the examples. Example 4. I said I would leave others for you, but I can see that let's just complete all of them. That's very easy. Now look what I have here. The question was that find the log of 1 out of 15, 6, 25 to base 5. So I didn't know what this one was, so I said let it be x. Oh, this time I said y. Let it be y. And so the next thing is obvious. You just have to write this in index form or exponential form. So this 1 out of 15, 6, 25 goes the other side where y is, and y replaces it. That's what you see here. So the question is, can this 15, 6, 25 be written in terms of 5? Let's just see. Can it be written in terms of 5? It is 16. No, not 16. But it's 15. 6 and 5. And I want to see how many times would 5 go there. 5 into 15 is 3. Into 6 is 1. The remainder of the 1 into 12 twice because of 10. And the remainder of the 2 into 25. 5 will go there 5 times. 5 would still go into this number. Into 31 6 times. The remainder of the 1 into 12 2 times. The remainder of the 2 into 25 5 times. 5 will still go here 1. The remainder is 1. When it goes to 6. Into 12 will go there twice because of 10. The remainder of the 2 and into 25 go there 5 times. 5 can still go here twice. The remainder of the 2 and then 5. 5 to go here 5 times. and 5 to go here 1. So that means 15, 625, the same as 5. 1, 2, 3, 4, 5, 6. But what I have is 1 out of 15, 625. That means this is the same as 1 out of 5 raised to 6. This is a positive number, positive power here. If I took it to the numerator, this would be the same as 5 raised to negative 6. 5 raised to negative 6. And that's what you see here. That's what you're seeing. 5 raised to negative 6. So that means 5 raised to negative 6 is the same as 5 raised to y. The bases are the same, meaning that we then equate the powers. So y is negative 6. So that then means that the log of 1 out of 15, 6.5 is the mass negative 6. I had to take this to the power, so to the base. You see, this is what it was. This is what it was. 1 out of 5 raised. I wanted the 5s to be all of them in the numerator, together with their powers. All of them to be in the numerator so that I can equate. I can never equate when one is in the numerator, the other one is in the denominator. That's why I had to take this one to the numerator. That I have 5 raised to negative 6. So one might be wondering why we had to do that. And that is the reason. You can never equate the powers when the bases, one is in the numerator and the other base in the denominator. What was the other question? The other question was the log of 1024 to base a quarter. Actually, I didn't know what it is, so I said let it be m. Let it be m, and that's what you see here. That means when you say let it be m, then m has to take the position of 1024, and the 1024 has to take the position of m. And so this is what I get. 1024 equals to a quarter raised to m. So then I write 1024 in terms of 4. I found that it would be 4 raised to 5. And then this one, a quarter here, a quarter raised to m, it is the same as 1 raised to m out of 4 raised to m. But 1 raised to m is just 1. 1 raised to any number is just 1. So this is the same as 1 raised to 4 out of m. Now I want the bases to this to be in the numerator so that I can equate. So this is the same as 4 raised to negative m. So that is why you see this 4 raised to negative m. So now the bases are the same. We can equate the power. And so when you get those powers, you get that negative m is 5. But I need m, so I divide both sides by negative 1. And I get negative 5 in the value of m. That means, therefore, that this thing is negative 5. Now, have we exhausted the question so that we look at the question is not exhausted. We are at number 5. We still have number 6, 7, and 8. Let's just look at number 6, 7, and 8. Number 6, they wanted this, but I didn't know it, so I said let it be t. Let it be t. So if it's t, then it means that t has to take the position of 243 out of 1024, and the 243 out of 1024 should take the position of t. And so that is what I've just done here. That's what I've done. And then this one, I try to write it in terms of 3 out of 4. I tried to write this one in terms of 3 out of 4. And I found that it was. So what you do, express this one in terms of 3. And express this one in terms of 4. And so what you get. That's what I did. Let me just show you that. 2 for 3 alone, in terms of 3, through go there with 81, through go here 27 times, through go here 9 times, through go here 3 times, and then finally 3 goes there once. That means 1, 2, 3, 4, 5. How about 4? This one in terms of 4. 10, 24, 4 goes here twice. Because of 8, the remainder is 2. Into 22, 4 goes there 5 times. Because of 20. And then into 24, goes there 6 times. Again, 4 will go here. 6, 4. 4 will go here. 1, 6. 4 will go here. 4. 4 will go here once. 1, 2, 3, 4. So that what that therefore means is that this number here is the same as 3 out of 2 out of 4 raised to 5. That's why I wrote it here. So I just looked at this and looked at this. So I sought to write this in terms of this and this in terms of this. So the bases are the same, 3 out of 4, 3 out of 4. So the power of 5 equals to t. And so I make my conclusion. Now let's now come to this question 8. Question 8 says, find the natural logarithm of the 5th root of e. At the beginning, I already said that this would be the same as a log of. Whenever it's natural logarithm, the base there is e. And we are finding the 5th root of e. So I've written this one in terms of log. So I say let this be x. Then I write in the index form. So x has to take the position of this power. And that's why you see that I've written x raised to e because the 5th root of e. In fact, this is just the same as e raised to e. So the base is the same. The base is e, the base is e. That means that x is 1 out of 5. X is 1 out of 5. From here, I don't think I concluded. I didn't conclude it. Or let me just check. Let me just check if I did the conclusion. Just goes. Yes. Oh yeah, I did the conclusion. I did the conclusion that it x will be 1 out of 5. Okay, number 7. Let's just go back to. I've done number 8 before number 7. So let's just do number 7 now. Number 7, we are required to get the logarithm of the 8th root of 243 and the base is 3. So we don't know it. Let's just let it be s. Let it be s. So let it be s, then s has to take the position of that and so this one replaces it. So we have the 8th root of 243 being equal to x raised to s. And that's what I wrote here. So then write 243 in terms of 3. we have done this one earlier. We have found that it will be 3 raised to 5. So then, if that is the case, then what I have here is the 8th root of 3 raised to 5. The 8th root of, just write open, 3 raised to 5, the 8th root of that, to give you, this is 3 raised to s. The bases are the same. That means s should be the same as 5 times an 8, which is 5 out of 8. And that's what I did. So you can follow this working. And for the sake of the notes, you can copy what I have on my slide. Let's look at the other concepts. Laws of logarithm. So let's just look at the laws of logarithms and then apply them. And again, you are very much familiar with these laws. That if you are given log of a plus log of b, this is the same as log of the product of a and b. For instance, if you are given log 2 plus log 3, to simplify it, it is the same as log of 3 times 2, or log of 6. And subtraction here will be treated as division. So the log of a minus log of b will be log of a out of b. For instance, if I'm given log of 2 divided by minus log of 3, this will be the same as log of 2 out of 3. And then the other law is that the log of a raised to n will be the same as the n goes before the log, so it will be n log of a. For instance, if I'm given log of 5 raised to 2, I would write this 2 here with 2 log of 5. And remember, this is 10. This is silent, so it's 10. And the other important thing that I want us to note that we'll be using is that the log of a number to the same base is 1. So the log of a to the same base. E.g., if I'm given the log of 3 to base 3, the answer should be 1. Even the log of 7 to base 7, the answer will be 1. So that is very important. And the other very important thing is this point number 2 here, is that the log of 1 to any base, even if the base is 7, the answer will be 0. The answer is 0. Now, so the other interesting thing is that we can change the bases. That is, if you're given the log of b to base a, then this can be the same as, I can interchange this to be b to become the base and a to become the log. So it will be the log of a to base b. So these are same as this. When you interchange what was the log to become the base. And those ones are very important if you'll use them. Now, we've done these questions before, but I want to do it now using the knowledge that we just learned. But we've done it before, but I just want to use the knowledge that we just learned. I want to write this one in terms of 5. What I know is that part 1 is the log of, I already have the answer here. Forget about Forget about the question mark here. I'm saying that we have already seen how to evaluate this kind of questions. It's supposed to be in the above example. And another example above. In the above example. So there's an example above that I'll show you how to do this kind of questions. But then I want to show another way of doing it. Part 1 here will be the log of 5 raised to 2 to base 5. 25 is the same as 5 raised to 2. So when I use the laws of logarithm, these 2 should be written here. 2 log of 5 to base 5. And we just said that when this is the case, the log of a number to the same base is 1. So this part here is 1. This part is 1. So what we have is 2 types, which is just 2. And that's what I did. That's what I did here. So that is the result to this question 1. What about question 2? I want to do it again. 81, I write 81 times of 3. So 3 goes into 81. This is 2, 7. 3 here, 9. 3 here, 3. 3 here, 1. So 81 in fact is the same as 3 raised to 4. But what I want is a log of 81. But 81 is 3 raised to 4 to base 3. So this one 4 can be written before the log, and I have 3 to base 3, which is 1. This is 1. So 1 times 2, the answer is 4. And you can see how easy it is to do this kind of thing. We show the workings because I had already done these questions. So we've done question 1, question 2. We now want to look at question 3, 4, 5, and so on. For the sake of time, let me now show you the workings. Now, so the other question that we were asked was to find the log of 8 to base 32. This one I noticed that I could not use the same method. I noticed that I could not use the same method that I've used in question 1 and 2, and so I then resorted the earlier method where I say let x be this, and then write in the index form x goes to where 8 is. So I have 32 raised to x is 8. Then write 32 in terms of 2 and 8 in terms of 2. Because I notice that 2 is the only number that is common. That I can express 8 in terms of 2, not 4. I cannot express 2 in 8 in terms of 2 as but I can express 8 as 2 raised to 3 and 32 as 2 raised to 5. So 32 is 2 raised to 5. Then raise it to x. That gives us 2 raised to 5x. And 8 is the same as 2 raised to 3. So the bases are the same, just equate the powers. 5x is 3, and therefore x is 3 out of 5. Question 4. This one I can do it using the method of example 2 and 1. And so I have to notice that the base here is 10. Silent, so we said it to be 10. So what I have is log of 10 raised to 2. 100 is 10 raised to 2. Base 10 can be written as 2 log of 10 to base 10. But this is 1. So 1 times 2 is 2. And that's how I get that. Let's now do this question 5. I can write this in standard form. This number, you write it in a standard form, and it will be 1 times 10 raised to what? 1, 2, 3, 4. Negative 4. So we all know how to write numbers inside the form. And so that means that if I'm given this number, I can write it as this. But I know that 1 times 10 raised to negative 4 is just 10 raised to negative 4. It's just that. So then what I then have, and remember the base is silent, so it's 10. So what I then have is the log of 10 raised to negative 4 base 10. Then take negative 4 the other side using one of the laws of logarithm. I would have negative 4 log of 10 to base 10. And this part gives you 1. Because we say that the log of a number to the same base is 1. So then it's negative 4 times 1, which is negative 4. Number 6, again, we will just think in the same way. I want to write 125 in terms of 5. And another 125 is the same as 5 raised to 3. But what I have is not 125. It's 1 out of 125. So it's 1 out of 5 raised to 3, which can be written as 5 raised to negative 3. And so therefore, what I have here can be written as the log of 5 raised to negative 3 to base 5. You know how the negative 3 came in. We already talked about indices earlier. And so, using that law of logarithm, the negative 3 comes before log. So I would have negative 3 log of 5 to base 5. And this is 1. Remember, I'm just exploring another method. We already done such examples earlier, where we are letting it be x and then write in index form and then solve it. You could still use that answer, the direct form of working, but I just want you to have a good and many ways of doing this kind of questions. Now, so what was this question 7? Let's just go back and see what it was. Question 7, so that we know what we are doing. Question 7 was this: ln of e, and I remember I introduced a way of doing that ln can be written in terms of logarithm to base e. So it was ln of e raised to 2. That was the question. But this ln of e means log to base e. And then e raised to 2. That's what I've just written here. That's what I've just written. So that means that 2 can come, and we have the log of e to base e. So this is a log of something to the base that is the same. So that means this is 1. That's why you get 2. And then lastly, you want this 0.25. Because if you are doing this question in an exam, you may not think in terms of 4. You may not think in terms of 4, but it's easier to think in terms of. So if you don't think in terms of 4, then just let it be x, and then write in index form where x goes to where 0.25 is. Where you have 0.25 is 16 raised to x. So what is this? This is just a quarter. And this is just 4 raised to 2 raised to x. But a quarter is 4 raised to negative 1. And this is 4 raised to 2x. That means the bases are the same, and you can therefore say that 2x is negative 1, or that x is negative 1 out of 2. X is negative 1 out of 2. You can do it that way. I don't know. Let me see whether I did it up to completion, because I'm not seeing my answer here. Let me just scroll down and see whether I have that answer. Yes, it's there. X is negative 1 out of 2. That's how you do this question. Let's proceed with the next concept. Oh, there was another question. There's another question. And the question was, what was this question 9? Let's just go back and see what it was. Question 9 was find the log of negative 27 to base 3. The log of negative 27 to base 3. And what is my answer here? I've said that the log of negative 27 to base 3 is undefined. Undefined because you don't find the log of negative number. Not find the log of a negative. That's why I'm saying that it's supposed to be positive real numbers. Only find the logarithm of positive real numbers. Now, so we've already exhausted what we needed to know about logarithm, but from just showing you very many examples and so many other ways of doing. Look at this. I'm saying that we can also solve equations. So this time we want to solve equations, find unknowns. And this one we've already done by use of writing from logarithmic notation to exponential form. So I just do 3 examples, and then we proceed with the rest. Number 1, just write this in index form. It will be 3 raised to 4 is m. That means that m is what? 3 raised to 4 is it 81? Just 3 times 3 times 3 times 3. Then of course the first is 9, that'll be 81. What about this other one? Number 2. But so I found that m is 81 for question 1. What about question 2? What is x? I know that the question that I have there is x to base 10. Because the base is silent, so I make it 10. And this is 2. So I write this in index form. It will be 10 raised to 2 is x. That means that x is 100. That's what it means. But these are simple questions. Just solving. What about question 3? Question 3 is ln of x is 1. But what is this? This one we said we can write this as log of x to base e. Log of x to base e is 1. So that means that x, write in index form, and x will be e raised to 1. So just use your calculator and see what you get. What is e raised to 1? I had already done this question, so let's just see what I've done. Yes, I found 81, 100. X is e raised to 1, so just e. Just e, in fact, e raised to 1 is just e, which is, you already know what the value is from your calculator. Now, what was this other question? Yeah, question 4 is find x if the log of 16 to base x is 2. Let me just write what the question is saying. Now find x if the log of 16 to base x is 2. Just write this in index form. X squared is 16. X squared is 16. So get the square on both sides. X squared on both sides. So x is plus or minus 4, the square root of 16, but reject negative 4. Why are we rejecting negative 4? We say that the base must always be positive. That means x is just 4. X is just 4. It can never be negative 4 because the base is supposed to be positive. Now let's see what I did. It's easier if we follow what I did for the sake of those who are writing notes. For the sake of those who are writing notes, this is the question. And I've said reject negative 4. And I've already given you the reason is that the base is supposed to be positive. X is the base, so it can never be negative. Actually. Question 5. I've done it. That find x when the log of 6x minus 5 to base x is 2. So what I did, I just wrote this in index form. I would have x raised to 2 is 6x minus 5. This is a quadratic equation. Quadratic equation. We know to solve them by either factorization, quadratic formula, or even completing the square method. But factorization is easy, and I did factorize. Found that x will be 1 or 5. But I rejected 1. Why? Because we said that the base is supposed to be greater than 0. The base is supposed to be greater than 0. And is not supposed to be 1. When you go back to the definition of the logarithm function, you get the definition of the logarithm function. And you can see that x is a base here. So it can never be 1. And it's supposed to be greater than 0. So we then are left with only one option, that x is 5. Let's look at another concept. Now this one if we are to use the laws of logarithm. You remember we said that where there is addition, we'll be doing multiplication, and where there is a subtraction, we'll be doing division under the laws of logarithm. So I've already done this, and you can see division here, you can see multiplication and subtraction and then addition. So what I have in question, this one is being multiplied. The sign before it is addition. So I would have, let me just rearrange. What I have is log of 8 to base 3 plus log of 16 to base 3 minus log of 4 to base 3. So I've just rearranged. And remember, it's multiplication where there's division. No, it's multiplication where there's addition. Remember, it's multiplication where there's addition, and then division where there's subtraction. So that means I have the log of 8 times 16 divided by 4, base 3. That's what I wrote here. The base of, the log of 8 times 16 divided by 4. So you can see that this will go here 4 times. So I'll be having the log of 32 to base 3. And I sought to write this one in terms of simplified further. And I found that 32 was the same as 2 raised to 5. So it's the log of, this same as the log of 2 raised to 5 to base 3. And then using another log logarithm 5 goes there. That's what I wrote. So the question was just simplified. So we just simplify it using the laws of logarithm. What about this question 2? I can see log of 8 plus log of 12 minus log of 14. That means log of 4. Let's multiply where there is addition. The log of 8 times 12 divided by 4. Which will be what? Which will be log of, this will go there twice. It will be log of 4. The best here is 10. You can just leave it the way it is. And leave it this way. Let me see what I did. Did I leave it that way or I simplify it further? Yes, I left it that way. I left it that way. I left it that way. Now, so let's look at this other one. We are given natural logarithm of 2, and remember what this one is. And then plus natural logarithm of 14 minus, these are logarithms. So where there is the sum, this is natural logarithm of, I'm doing the numerator, then the denominator remains here, natural logarithm of 9. So the numerator we have 2 times 14, then divided by 7. 2 times 14 divided by 7. That's the numerator. The numerator 2 times 14 divided by 7. So this is natural logarithm. The numerator will then be natural logarithm of 4 over 2 natural logarithm of 9. But if 4 can be simplified to be natural logarithm of 2 raised to 2 out of 2 natural logarithm of 9. And using our law of logarithm, 2 would go before the natural logarithm. So I would have 2 natural logarithm of 2 out of 2 natural logarithm of 9, where 2 and 2 will cancel. And that is why you find that I have my answer is supposed to be. Oh, this one can also be simplified. My answer is supposed to be natural of 2 out of natural logarithm of 9. But 9 you can also simplify it to be 3 raised to 2. Natural logarithm of 2, natural logarithm of 3 raised to 2. So 2 would come here. That's what you see here as my answer. That is my answer. That's the reasoning there. Now, so the good thing is that you can listen to these videos again and again, and when you find that you've reached somewhere that you are tired, you can still continue next time. But I have to look at the whole topic. Now, let's look at this, evaluate this. Again, we just be using the laws of logarithm. You can see subtraction here, which will mean division. You can see addition, which will mean multiplication, and so on. So that means, in fact, I began by simplifying this. It's not necessary, but okay. I can check this on the other side. Take it back as a power if you want. Take it back as a power. Or if you want to simplify this. Now, you can follow this method, but let me use the other method that I want to use. This one is easier. This one is easier. I just simplified and collected like terms. Let me just explain this because the other one you already know it. The other one is when I wanted to multiply. In fact, I wanted to do this. I wanted to say that the numerator will be the log of 496 raised to a third times 16 raised to 2 divided by 64. This is what I wanted to say, that this is our numerator, And then the denominator is log of 7. Now this is 4 raised to 7. The base is still 10. The base is still 10. Now, so you can try this. You can try this later and see whether you get the same answer. Of course, this 7 can be written here. This 7 can be written here. You can try this. You can try. This is 4096 raised to a third times 16 raised to 2 divided by 64. The whole thing divided by 7 log of 4. And see whether you get the same results. Okay, let's see the other one. And the other one, again, you can use the method I've just talked about and see whether you get the same results. But this one looks simpler. This one looks simpler because this is just log of 5 raised to 2. And this is 5 raised to 3. 5 raised to 3. But then it's raised to a third. It's raised to a third. Then out of 2 log of 5. So what do you get here? Let me write this as 2 log of 5. And these will go here once. Just log of 5. Of course, if you want, you can write here 1 if you want. And this is 2 log of 5. And then you can now subtract 1 from 2 to get 1 log of 5. And this is 2 log of 5. Since you have log of 5 and log 5 of 5, they can cancel out and they are left with the half as the answer. Now, you can do as many examples as possible to ensure that you familiarize yourself with the laws of logarithms and their applications. Now, I want to show you this example, and then I'll show you the same example using another method. And the question is, you're given the log of 2 as 0.30103. You're also given the log of 3 as 0.47712. And we are required to use this to get the log of 9. So this question is about you to think of how to express 9, either in terms of 2, or in terms of 3, or in terms of both 2 and 3. Yes, upon you to think of how to do this. Let me see. Log of 9 is the same as a log of 3 raised to 2. The same as 2 log of 3. The same as 2, but we know what log of 3 is. The question has given us that as 0.47712. So when you multiply, you then get 4, 2, 4, 5. That this will be 9. 0. That will be the log of 9. And we've not used a calculator, just used the knowledge of log of 2 that we are given and the log of 3 that we are also given. So let me show you the other workings because I already have them, and just so that I just explain. So we've already done this log of 9. Now we also have log of 6. We think of how do we write 6 in terms of either 2 or 3 or both. 6 would be 2 times 3. And by law of logarithm, this is the same as log of 2 plus log of 3. By law of logarithm. So that we know what log of 2 is that, and we know what log of 3 is that. So just now add and get your answer. Now what about 12? How do we write 12 in terms of either 2 or 3? Let me see 12. 2 would go here 6 times. 2 would go here 3 times. 2 would go here once. That means 12 is 2 raised to 3, 2 raised to 1, 2 times 3. So in other words, this is what I wrote. The log of 12 is log of 3 times 2 raised to 2. And by law of logarithm, this is addition. Log of 3 plus log of 2 raised to 2. But this one can come here. By law of logarithm, and you can switch here. Now, we already know what this one is this. And we already know what this one is this. So, we just then do it. Multiply 2 by this, and then add the result to that to have this. Now, so I want a half. The log of a half. I ask myself, how do I write a half in terms of 2 or in terms of 3? And I notice that a half is just the same as 2 raised to negative 1. So I'm talking of log 2 raised to negative 1. So 1 can come here, negative 1. And I have negative 1 times log of 2. But log of 2 is known. Log of 2 is 0.30107. So when I multiply that by negative 1, then I arrive at this. Okay, let's go to the other questions. Maybe those ones may require much thinking, but the first two ones do not require a lot of thinking. Question 5. Yes, good. Question 5 says, find the log of 1.5. So I think of how do I write 1.5 in terms of either 2 or 3? 1.5. But from our law primary, we already know that 1.5 can be written as a fraction as 15 out of 10. It can be written like that. And that 5 can go here 3 times, and 5 can go here 2 times. So what I have is 3 out of 2. That's good. Look at that. I've just thought of how do I write this in terms of 3 and 5. And in fact, I didn't use a lot of reasoning. I only converted this to fraction. I only converted 1.5 to fraction, and it gave me 3 out of that. So that means that instead of writing log of 1.5, one can write log of 3 out of 2, which by law of logarithm is the same as the log of 3 minus log of 2. Same as log of 3 minus log of 2. And the log of 3 is known, log of 2 is known. So you only need to subtract to get the log of 1.5. We've not used a calculator. We've used the information given to us. Let's look at this. Again, I'm thinking of how do I write this in terms of. Look at this. Look at the base. Look at the base. The base is 3. So what do we have in fact? How did we arrive here? How did we arrive? Let's go back to the question. Oh, no, the question is, let me just erase. The question is find the log of 100 to base 3. And what is given to us is the log of 3 and the log of 2. That means 3 should not be in the base. What do I have here? The log of 10 to base 3. The log of 10 squared to base 3. This is the same as 2. The log of 10 to base 3. And when I interchange the bases, this is the same as 2 times 1 out of the log of 3 to base 10. And this is what I want. This is what I want. Because I know what the log of 3 to base 10 is. So it's the same as 2 out of 0.4771. Because this is the log of 3 to base 10 is 0.477. So it's only at this point that I can use a calculator. It's only at this point that I can use a calculator to get these results. But the rest, I was just thinking in terms of what is given to me. Finally, we now know how to do this question because we've done a similar question here. Number 7. But I was to begin with number 6 and I forgot and began with question 7. There's no problem. There's no problem. What I have there is number 6. What I have is the log of 10 to base 2. But 2 should not be base. 2 should not be base. So I should have it as 1 out of log of 2 to base 10. But log of 2 is known, is this. And so you can use your calculator. Only at this point you can use your calculator and get these results. But the working must be seen there. Okay, let's look at another interesting concept. Oh, these examples, again we are solving. We had looked at how to solve earlier, but I thought that this would require another way, or I just want to introduce another way of reasoning. And just try a few. The first one is very easy to us. Just write it in index form. It will be 4 raised to 2 is x plus 4 when you write it in index form. And of course, 16 minus 4 would be x. Because this is 16. Take for the other side. So x is 12. That's how I did it. So very easy things. I want to do this. And I'm using the laws of logarithm. This addition, so it means I'll be doing multiplication. So I would have log of x plus 4 multiplied by x minus 5 is 1. Remember the base is 10 actually. Yeah, that's one way of doing it, and it's a very easy way of doing it. The base is 10, then now write this in index. You would have 10 raised to 1 is x plus 4 multiplied by x minus 5. This is a very simple way of doing this question. There could be other ways of doing it. The other ways, I know the other ways you may want to write this one as log of 10 to base 10. And then take it the other side. Okay, so what is this? 10. This is x squared. Just expand this. You know how to expand. X squared minus 5x plus 4x gives you minus x. And this other one gives you minus 20. That means x squared minus x minus 30 is 0. And this can be factorized. We look for two numbers whose product is negative 30 and the sum is negative 1. And those numbers are negative 6 and positive 5. So x squared negative 6x positive 5x minus 30 is 0. And so x will go here. X minus 6 plus 5 into x minus 6 is equals to 0. X plus 5, x minus 6 is 0. So x is negative 5 or x is 6. So you come back and see if x was to be negative 5, what will happen? If x was to be negative 5, because I have no problem with the positive 6, I have a problem with negative 5, so I have to check whether it will accept first of all. If x was negative 5, this point I would have negative 5 plus 4, which would be negative 1, and that would not be accepted because you cannot find logarithm of negative numbers. So that will not be accepted. In fact, even at this point again, it will be negative 10. The log of negative 10, that will not be accepted again. That means that we are left with we reject this and accept this. Okay, so let's just go to my working. Let's just go to my working so that people can copy the notes. Those who are copying notes. Working for question 2 is here. Yes, that's what I've done. Oh, that's what I've done. And I've said that reject negative 5, since this log would be undefined. Since if x is negative 5, we would have log of negative 1, which would be undefined. And therefore we are left with only one option, that x will be 6. Oh, look at this other question. Very interesting. Let's do it. It's interesting because I can see x here, and the 2 is in the base, and x is also here. But now, what is interesting here is that the bases are 2, and therefore the bases, we are adding, and therefore it can multiply. Therefore, it can multiply. So what I have is the log of x times x minus 2 to base 2 is 3. What somebody will want to do, will want to write this one as in terms of log to base 2. That is another way of doing it. But I just want to use the one we've used before, where we are writing index form. 2 raised to 3 is x squared minus 2x. When you write in index form, and you can see that I then have x squared. If I take this on the other side, minus 2x minus 8 is 0. So that's what I have. And you can factorize, proceed, reject what is negative, and then it's not always that we reject, but we come and try and see. We try if it will accept. If it accepts, if it doesn't give us a negative value here, there's no problem. But this one gives us a negative value, so there's a problem. So we reject this negative 2 and remain with this. I want to finish. I want to look at a few other concepts, and then this one you look at it. You look at it. You look at it. Yeah, same concept. That this is not. First of all, I brought it back. I brought it back. Brought this one back. This I have. Bring it back as a power. This I have. Bring it back as the power here. And because of this addition, and since they're doing the logarithm, it will be multiplication. So there's no problem, just follow the work. It's very easy there. Okay. Now, so what have I written here? I've said that in what follows, we use laws of logarithm to solve certain equations involving powers. We achieve this by introducing log on both sides of the equation and then simplify. So we are given an index equation and we are asked to solve. Of course, the first one is easy. The first one is easy, but you see the first one, somebody can just write it this way. The way we did earlier. This was just a rest. 2 raised to x is equals to 2 raised to 4. The way we did it earlier. But this is not the method I want to use. because I said I want to introduce as many methods to you as possible. So the method that I want to use is the one I've just stated here, that I'll introduce logs on both sides. So I'd say log of 2 raised to x is equals to log of 16. And then x log of 2 is log of 16. And then x is log of 16 divided by log of 2. You can use your calculator. I need your calculator, but I do not want to do that because I know that 16 is the same as 2 raised to 4. And this is log of 2. And this is 4 log of 2 out of log of 2. And that this can cancel to leave me with 4. So there are very many ways of doing these questions, but I want you to learn all of them, master all of them. You can apply any if you're given a question and a method has not been specified to you, you can use any. Now, so I want to do question 2. I not do it because it's the same thing. The same thing that it just includes logs on both sides. But let me just do it. Introduce logs. So it will be log of 4 raised to x is equals to log of 7. So this will be the same as x log of 4 is equals to log of 7. Make x the subject of the formula. Log of 7 divided by log of 4. And here you can use your calculator. Because this one cannot be simplified further. Use your calculator. Take log of 4, that is log of 7, get it, and then divide by log of 4. You should be getting something like that. Just use your calculator. And look at this one. This one is very easy. What was it? Just go back and see what it was. Oh, it was question 3 is this. It's good for you to be coming back and seeing what the question was. Introduce logs on both sides. Log of 3 raised to 2x plus 1 is equals to log of 5x minus 3. Then these ones can be taken the other side. 2x plus 1 log of 3 is equals to x minus 3 log of 5. This one side in brackets. This one side in brackets. Now, make the unknowns the subject of the formula. Make the unknowns the subject of the formula. That means I can divide this side by x minus 3 log of 3, and also divide this side by x minus 3 log of 3, so that this one cancels and this one cancels. I'm left with, what am I left with? 2x plus 1 out of x minus 3 is equals to log of 5 out of log of 3. Use your calculator to find these points. Once you have this, you can use your knowledge to find the value of x by cross multiplication and making x the subject of the formula. You can see it's getting dark where, yeah, it's dark here. Actually, it's dark here. But let's continue. Now, I don't need to go through all the questions. Look at the workings, and if you have any problem, just do not hesitate to ask. You can send a comment. Now, this is the last bit of it, and I want to introduce something very important. That if I'm given the log of b to base a, I can write this as log of b over log of a, and that will give me the answer in a very simple way. And even this one, if I'm given the log of b to base a, I can also write as the natural logarithm of b over the natural logarithm of a. So that if I'm given log of this, I can express it this way. And this, I can also express it this way. And that's what I want to do. So I want to do it. And you see, we've answered this question, this example before, but I just want to use this knowledge that I've introduced here. I just want to use this knowledge that if I'm given this, I can write this in a very simple way, that it will be log of 8 out of log of 6. Then I'll think of how do I write 8 in terms of 2 and or 3 or both. Then I think of how do I write 6 in terms of 2 or 3 or both. Now, if these ones are missing, then you could use a calculator straight away and get the answer. But they've been given to us. So that means there's no need of using the calculator. So let me just show you now what I did, because you already know how to do this, most of these things. I'm just introduced to that. I've just said that the log of 8 to the 6 is the same as log of 8 out of log of 6. And I've noticed that 8 is the same as 2 raised to 3. And that 6 is the same as 2 times 3, which would mean addition here. But this one, 3 can go the other side. 3 log of 2, which is known to us as 0.3 something. And this other one is log of 2 plus log of 3. But those ones are known to us, so you can do it. Okay, so I leave the other work as the exercise to you. But of course, I show you the workings that I have. And as exercise, you try later as you compare with my workings. So the other working is here. That's question 4, question 3. This is how I do it. And so you just do the questions and compare your answer with mine. And that is about indices and logarithms. Thank you for having given me company from the start to this end. Ensure that you subscribe to my channel so that whenever I upload videos, you are able to automatically get them. Thank you.